So, fun with Unreal Engine materials. We're going to quickly drag out some shapes. Obviously, they can be any shapes. And we're going to create material for them, very obviously. So first things first, we want to get some shapes. Let's just move them a bit closer together. That's good. And obviously you can see that they've got material on them, but we're going to replace that. So let's go into our materials folder and create a new material. So yeah, create new material. Let's call it we're going to call this Ignaro. Now I'm using the word master as a sort of default kind of thing, and I'll show you why in a sec. So if you see that there's a material slot here with a bunch of material domain kind of settings, and you'll see that those things change. Essentially that's the output node that we're going to have like the material output into. So as you change the settings for things like masked and those kind of things, you'll see that the input, they create new inputs on the actual material node. So think of the material node as the output node, and we need to plug things into the sort of values in the output node. So let's create a simple one here. We'll call it, if you press 4 on the keyboard and then click on the space, you'll actually get a 4 vector floating point thing, which is useful as a color. So here I'm just setting the color to a sort of orange with a color picker. Orange Ignaro, you see? Yeah. And that's going into the base color output. So what you'll see is that once you apply it, you can drag that material onto these shapes and they'll become orange. Pretty much simple, right? So that's your first material, and essentially that's the simplest kind of material shader thing that you can do. You can make it a little bit lighter by changing some of the parameters, but yeah. So that's the master material. And now what you should see here is that the master material doesn't necessarily update these things quickly. So you notice there when I changed the color, and I had to hit apply, and it took a few seconds to get onto the actual objects. And that's because it's recompiling the shaders. It's essentially restarting the shader. It's redoing the shader graphs because there's lots of different calculations. So what I've done here is, instead of doing that, I've changed it to a parameter. So that the color node, we've just changed the name of the actual node. We've changed it to parameter and set the parameter name to base color. So now when we apply, we've now got a parameterized shader. So we can go here and create a material instance from it. And let's give it a name, Ignaro_inst. It's useful to use naming conventions for these things. So we can drag that onto the shapes. Now you haven't seen any difference here now, but now they've obviously got that new material on. So if you look at the material node, the material in the material editor, you'll notice it's not editable anymore. That's because it's kind of pre-compiled the shader for it and just given us the parameters. So now if we edit the color parameter, we can actually change those values, and you see how it doesn't recompile? It's changing those values on the fly. That's because it's a parameterized, it's essentially like a compiled function that we can supply the parameters to. So that's really actually quite useful, because generally you'd make a bunch of master materials and then you would create material instances, and the artist would use material instances and get instant feedback. So you generally don't have that many master materials. And because the material instances are created based on the master material, you can actually change the master material's properties and the instance properties will change as well. So you've got to be kind of careful that you don't, destroy some of the inputs and those kind of things. So it's useful for you to look at the different types of materials that are available. They have different input properties, so you can see there's different sort of things here that some of these will be switching on and off depending on what your material domain is and material settings. Some of the values are, pixel based, some are screen based. There's different mathematical calculations you'd use for different ones. So have a look through the different types and just see what inputs they expect. There's quite a lot of combinations here, and obviously you don't have to supply every single input on all of them, but it's useful to get to know them anyway. So generally you would stick with the surface, opaque, lit. You can go for unlit, and that gets rid of some of the lighting, but obviously then your input nodes change because you've got obviously here you can see that there's no lighting, so you'd actually have to apply the emissive color if you're going to do an unlit material. So you notice that, like, when I changed that to unlit, it didn't have an emissive color, so now we'd have to plug in the emissive color for that to actually work, and obviously now it's not lit, so it's essentially full bright, which is useful sometimes if you want things that way, but it's not that often. So default is surface lit and opaque, so yeah, I would definitely go with that. Now notice here that I've got the emissive color still in, so we get that sort of full bright quality still. So we take that out, it's back to the normal orange. So essentially we've parameterized our material, which is kind of the main takeaway from this part of it, is just that we can make parameters out of a lot of these inputs. We can create new parameters, and that's what we'll be doing in the next material, is creating some new parameters to then play with as we're passing data into the material itself. So have a play with that, and then we'll come back to the next one.